Alrighty, so hello everybody. Welcome to day 3 of the BigBlueButtonWorld conference, the first session of the day. My name is Brendan Tager and I'll be helping moderate some of the sessions throughout today's event. So I'm really pleased for everybody who's taken the time out of their day to come join us, whether it's the morning, afternoon, evening. Big thanks, and a special thanks to you, Terry, for taking time out of your day to come give this exciting talk on how to reduce your hosting bill with BigBlueButton. Or how to reduce your BigBlueButton hosting bill. So before we dive in, I'll just give a little bit of an introduction on Terry. So Thierry Kauffmann is the principal engineer at Arawa. So founded in 2016, Arawa is an IT services company specializing in free and open source collaborative software. And so in this presentation, Terry will present the initial architecture setup, the process of reducing hosting costs initiated with the customer, technical solution implemented to do this, and the feedback after several months of production. So without any further ado, I'm going to pass the mic off to Terry and let you take it from here. Thanks, Terry.
Thank you, Bren. Hello, everyone. Thank you for joining this presentation. I'm going to introduce you to Divim-S project. It's called, it's an open source orchestrator for BigBlueButton that allows you to save on hosting costs. It's called Divim-S. You pronounce it Divim-S because originally it meant dynamic virtual machine scheduler. So first, I will show you the content of my presentation. I will talk about Arawa. I won't say many words because Bren already told you about it, the company behind the development of Divim-S. I will talk to you about the project that launched the development, then make a comparison between virtual machine and bare metal computers to host BBB servers, and why we made some choices. Then I will present a classic scale-light pool architecture. And then I come to what really interests us today is Divim-S, what it does. I'll show you the results because Divim-S is in production, has been in production for about 2 years now. And I will talk to you about the technical solutions that back Divim-S, and we'll see in the end future developments. Let me now present Arawa, the company behind the development of Divim-S. As you can see on the picture, at Arawa, we're not afraid to take on challenges. The company was founded in 2016 with the following objectives: to provide collaborative tools that users need, help organizations to keep control of their data, develop collaboration between employees and partners, and finally integrate open source collaboration software into the information system of medium and large organizations. We mostly work with those open source solutions like Nextcloud for document sharing, Collabora Online and OnlyOffice for online office tools, Mattermost for team chat, and BigBlueButton mostly for video conferencing. So I'm Thierry Kauffmann. I've been system administrator at Arawa for 3 years, and I'm the creator and main developer of Divim-S, which I will present in a moment. So let me now present the project that launched the development of Divim-S. The French Ministry of Education, it's called Ministère de l'Éducation nationale et de la jeunesse. It's France's largest employer, contacted Arawa in March 2020 when working from home became very fashionable. I think it rings you a bell. In order to quickly set up a video conferencing platform for the ministry's agents on the one hand, and the colleges and high schools on the other hand. The Digital Education Department, in charge of this project, implements digital solution for 1.2 million employees, 900,000 teachers, and 12 million students in middle and high schools in 17 academic regions in France and overseas. The request from the French Ministry of Education coincided with the release of Scale-Light, the load balancer for BigBlueButton developed by Blinds and Network teams. So we set up several pools of BigBlueButton servers, all with virtual machines to host BigBlueButton behind Scale-Light's load balancers. The pools range from 75 to 150 BigBlueButton servers attached to a single Scale-Light server. And to tell you more about why we chose virtual machines to host, the Ministry of Education has chosen from the outset to host BBB servers on virtual machines in order to benefit from the greater flexibility offered by this type of hosting. In addition, the Divim-S project was launched simultaneously to reduce the high hosting costs associated with the use of virtual machines. So why are virtual machines so more expensive in certain situations than bare metal? Maybe I'll do a little poll to know whether most people use okay, please let me ask a question. The question will be, do you mostly use bare metal or virtual machines to host BBB servers? And the answers are bare metal, virtual machine, and the last one will be I have no idea. Okay, please answer this tiny poll. Okay, most people have answered now. I will publish the results. Okay, so we see that virtual machines are used by most people, and bare metal comes second. Some people have no idea. I guess they're not administrators. What makes virtual machines more interesting? Well, in terms of performance per CPU, they're very good. Bare metal is the highest performance, but virtual machines are very expensive if you pay if you rate it on a monthly rate. On a monthly cost per CPU is very high for a virtual machine. But for a virtual machine, most of the time the billing period is an hour, whether it is month or bare metal server. And the startup time of a virtual machine is counted in minutes, whereas it is hours for a bare metal server. So the variability profile of virtual machines is the highest, since you can start in minutes, and you can stop them in minutes too. So this is why we chose virtual machines, although they're more expensive, but I'll show you why. You'll understand afterwards. This is the typical architecture of a pool of BigBlueButton servers placed behind a Scale-Light load balancer. Scale-Light implements the totality. So here is Scale-Light in the center. It implements the totality of BigBlueButton Server's API and acts as a single backend for the client application. Here you see the usage is as follows. A client application for BigBlueButton. You see Moodle on the diagram here, but it could be a Nextcloud plugin or WordPress plugin or Greenlight, or even B3 Desk, which was developed by the French Ministry of Education, that connects to Scalelight and requests the creation of a video conference room. Scalelight redirects the request to the list loaded BigBlueButton server at that moment, and afterwards the conference participants will be redirected automatically to the same server when they join. So you see here that each BigBlueButton servers is able to record the sessions, and all the recordings are stored on a central storage, which is available, reachable from Scalelight. What is important to note is that the number of BigBlueButton servers here is static or varies little over time, because adding or removing a BigBlueButton server from the pool is a time-consuming manual operation. You have to act on Scalelight to tell Scalelight that there is a new server when you want to add it. And in addition, the servers are always on most of the time in a classical Scalelight pool architecture, even at times when they are not in use. For virtual machine rented by the hour, this represents a considerable expense. This is where Divim-S comes in. So this is the same diagram, but I added Divim-S. So Divim-S, it's an application that runs on a separate server. And Divim-S automatically performs actions that are normally done manually by an administrator, or not done at all because you don't have time to. So Divim-S continuously adapts the number of BigBlueButton servers in the pool to the observed load. In detail, Divim-S performs 4 tasks. The first one is it gets information from a schedule manager in ICS format to know the forecast schedule. Then it interacts with Scalelight to know the load of the pool in terms of participants, number of participants and rooms, in order to be able to adapt the number of servers here, to add or remove servers to the pool, to drain the servers that need to be stopped. And it also acts directly on BBB servers. It queries BBB servers to know the status of the services. It runs, for example, the BBB-conf-status command to know the status of the processing of the records and the transfer to the Scalelight server after processing, and to determine if a server can be safely deleted when there are no more sessions on it. And finally, it interacts with the hosting control center API to clone new servers from a master image, remove servers, and replace servers that are down. Currently, only Scaleway Elements in France is supported as a hosting control center. So what are the results? What happens when Divim-S is integrated into a Scalelight pool? You can see on this diagram a typical Divim-S day um, for the French ministry's agents pool. The number on the left, the number of servers available at a given time is constantly evolving and dynamically adapts to the load or to a forecasted schedule. In the latter case, in order to compensate for an evolution that is too fast for Divim-S to react automatically. So you can see on the diagram the evolution of the number of active conferences, the green line, excuse me. This is the rooms here. It goes, the minimum is 0 and it goes up to 244. The scale is on the left. And the number of active BigBlueButton server, it is this yellow line here. You have the Legion here, and it goes down to 3 servers and up to 43 servers during the day. So during the night, if we look at this line, during the night until 8 AM, there are very few conferences. The green line is very low. And the number of servers is at its minimum 3 here. By 8 AM, you see that the green light goes up, and Divim-S reacts by launching new servers. At 8:30 here, the schedule calls for 15% of the available servers to be launched, and Divim-S launches the servers to reach this mark here, 23 mark. We have 23 servers ready to support every conferences at 9 AM. As the number of conferences continues to increase, the numbers of servers increases as well and reaches a plateau here. There's a slight decrease at lunchtime, and then a new maximum is reached here at the beginning of the afternoon for a very short time, followed by a plateau period again. Then there's a slow and steady decrease in the evening until midnight, when the minimum is reached again. So you see that the two lines are very well correlated, and the number of servers follows the number of meetings very closely a few minutes later. And because the servers are billed by the hour of use, savings exceed 50% in terms of money. Switched off servers only cost the rental of their IP address, which is negligible. In addition, the system allows for a high degree of flexibility and can react to unexpected high loads, like here, for a very short period of time. Here is the forecasted schedule used in the previous case. You can see there is a minimum of 15% of the servers in the pool are requested from 8:30 AM until 5:30 every day of the week, and only 2% in the evenings and at night and during the weekends. Any change when in the schedule hosted on Nextcloud is immediately active and allows to safely respond to large load. For example, if you are expecting 5,000 people at 9 AM, it may be useful to have all servers active by 8:30 AM to support the load when it arrives. What are the technical solutions that back Divim-S? Well, Divim-S uses the following technologies and systems: PHP 7.4. All code is written in this language. You may be maybe you ask yourself why we chose PHP. The answer is very easy, because I knew it. And we knew we could do it with PHP. We also use SSH for interaction with SQLite, which does not have an API, and with the BBB server systems. We interact with the Scaleway API, the author. We did our own implementation of the Scaleway API based on curl calls. We also make use of the BigBlueButton PHP API, the official PHP implementation of the BigBlueButton API made by the Brands and Networks teams. We use an extension of PHP, PHP Parallel, the official Parallel extension available since PHP 7.2 that allows parallel non-blocking processing in PHP. And the Nextcloud calendar, which provides a web interface for calendar forecasting. I did not mention Ansible that we use to deploy the master BBB server image. It's not required by Divim-S. There is no need to install anything other than Docker in the operating system. So how does it work? A cron task launches a Docker container every 5 minutes that runs the PHP code and performs the 4 tasks described previously. That is, get forecasted schedule, get current pools load, get BBB server statuses, and make a decision whether to start or stop BBB servers. The hosting API and BBB servers are queried in parallel to save precious time. Well, in the first version of Divim-S, the cron tasks run every 15 minutes, but many improvements in machine cloning obtained thanks to collaboration with the authors, Scaleway, have reduced the startup time of a new machine, including reconfiguration, to only 3 minutes. This makes Divim-S even more responsive to load changes and reduces the need for a predictive schedule. Installation is pretty straightforward and requires less than 2 hours for experimented administrator. What are the future developments for Divim-S? Well, the software code was open sourced as originally planned with the client in May 2022, that is a few months ago, on the code hosting platform gitlab.com. Anyone can fork the project and propose improvements to the main project in the form of a pull request. Divim-S is already functionally rich. The most expected evolution, and also the most difficult, is to develop the compatibility with other public virtual machine hosting platforms like OVH in France or AWS in the US, DigitalOcean, and others. Another evolution, easier to realize, is to make Divim-S compatible with another load balancer than SQLite, like B3 Scale, for example, for which a presentation is planned later today. That's all for my presentation. Thank you for listening. And if you have any question, I will be pleased to answer.
Thank you so much, Thierry. That was an amazing presentation. So we have about 7 minutes here to answer some questions. I see we have a couple here in the chat from Dimitri and Mark. So the first question from Dimitri is, anyone hosting BigBlueButton on something else, like containers or even Kubernetes?
I didn't know you could host BigBlueButton on Kubernetes. So Divim-S actually does the same as would do Kubernetes for containers. But I wonder whether you can host BigBlueButton in containers, since BigBlueButton itself uses containers to host, for example, a LibreOffice container. So I wonder whether you can host BigBlueButton in containers like Docker.
And we have another one here from Mark asking, does it only rely on a calendar or also adapt to unscheduled meetings?
Yes, it adapts. It uses both and makes the decision on the best guess. It uses a calendar for unexpected loads, and it also reacts to the real load, as you could see on the diagram. So it adapts to unscheduled meetings as well.
Great. And then we have one here from Brent asking, any tuning suggestions for running Big Blue Button on a virtual machine?
Well, we did not tune Big Blue Button to run on virtual machines. What we noticed is that it was running very well, as I told, and so we do not have I do not have suggestions about for tuning.
All right, and I think we still got time, about 4 more minutes before the next
Okay,
presentation starts.
Yeah.
So if anybody has any other questions, we'd really encourage you to go ahead and post them in the chat. Otherwise, if that's it, I'll go ahead and I'll stop recording.